Okay, I would like to welcome you in the name of BS Telecom. My name is Nerma Šečić-Haračić. Here is my colleague Nadim Bijelić. We will try to present you some things from industrial IoT and smart cities. Even we girls like to talk a lot. I will not speak about BS Telecom. I will let you watch a movie. We made it for our 15 years anniversary.
BS Telecom Solution Ltd is a company founded in 2002 and it has been present on market as manufacturer, supplier and integrator of complete telecommunication and information systems based on modern technologies and its own technological research.
Mi sa BS Telecom smo krenuli 2002. godine. Možemo reći kao mala firma sa 5 uposlenika. Danas pokrivamo puno veće tržište, imamo 70 uposlenika i kako sa ljudima smo radili, tako smo i sa znanjem, projektima i tržištem koje pokrivamo.
Prije završetka fakulteta sam počela raditi u BS Telekom, tamo sam radila diplomski, sad to nije bio BS Telekom, to je bio Strom Telekom. Nas troje faktički napravilo tu firmu, počelo. Do dan danas smo zajedno, mislim da smo dobar tim, što pokazuju u konačnici i naši rezultati koje smo ostvarili tokom svih ovih godina.
The main goal of BS Telecom Solution is to build an appropriate system which will make our client competitive and have better profitability. The concept of solution that we offer is always in accordance with the requests and needs of our clients and is based on international standards from telecommunication and information fields.
BS Telekom je uglavnom fokusiran na projekte kojima se bavi. Ne pokušavamo da divergiramo na tržištu, dobri smo u onom što radimo, neskromno mogu reći da smo sigurno jedni od boljih u stvarima koje radimo i mislim da su to i naši klijenti prepoznali.
In order to always progress and to fulfill clients' requests and to constantly improve its services and products, BS Telecom Solution has implemented quality management system in accordance with ISO standard 9001-2008. In last 3 years, on Corridor 5C through Bosnia and Herzegovina and Corridor 9 through Serbia, we have successfully implemented traffic control and management systems, covering 90 kilometers of highway route. Also, we projected and successfully implemented highway toll systems, totaling 6 toll places on 90 entry and 23 exit lanes on highway in Bosnia and Herzegovina.
Najveća snaga BS Telekoma su ljudi, naši uposlenici, to jest ja ih smatram prijateljima.
BS Telecom has a team of over 50 highly educated engineers, able to provide solutions and fulfill clients' complex requests. Our programmers' competencies enable us to efficiently use any developed platform in a short period of time.
Mislim da imamo ekipu koja je već godinama zajedno. Dobar dio ekipe je preko 10 godina zajedno. Mi jednostavno znamo kako dišemo. Dobri smo prijatelji prvenstveno i mislim da to čini dodatnu snagu, što smo jedan kompaktan tim koji sigurno sam da nema prepreke za bilo kakav projekat za BS Telekom.
Our new product, BS Husky, is a complete ITS solution. We come from telecommunication world. We worked with all the telecoms in Bosnia and Herzegovina and with some from Russia, Germany and Czech Republic, as well as with utility companies, electric power companies and water supply companies. There we implement CRM, BI, billing solutions, custom-made solutions, and system integration of specific solutions for special industries. For big projects, we offer outsourcing service with our local specialists on site, use our clients' capacities in order to minimize the time needed for project implementation. Our experience from telecom industry combined with ITS opens the door for a new big market, smart city world. Markets that we already cover: Russia, Czech Republic, Germany, Bosnia and Herzegovina, Serbia, and we are currently negotiating with Montenegro, Albania and Macedonia. We are satisfied with our success in previous 15 years, which is a result of productive cooperation with you, our dear friends and business partners. We are looking forward to the future because we are building it together. Yours, BS Telecom.
I have to say that we got the first contract in Montenegro, so this is a little bit old film. Okay, let us start with the official presentation. Agenda, we will say something about evolution of IoT, current state, industry challenges, platform organization approaches, BS Husky as platform suitable for IoT, platforms for smart cities, and something about smart city services. I will not speak about evolution of IoT a lot. I will just say that there are three waves. Definitely there is device IoT, consumer IoT, I will say. It is industrial IoT, and at the end it will be networked everything, networked society. We are definitely focused on the industrial IoT. I will try to compare evolution of BS Telecom, comparing it with evolution of IoT. We also started with end consumer applications. We were making first IoT application quite long time ago when term IoT did not exist. Then we started with some business application. As you heard, CRM, billing systems, a lot of different business application for industry. Usually it was telco industry and utility. And then we realized that definitely what is needed in each of those industries, that's some middleware. We were investigating what can be offered on the market, and we decided to make our own middleware. It was our first middleware, our first application, and it was not perfect, definitely, at that time. But then we started and entered that world of traffic management. We started with toll system and traffic management system for tunnels and highways. As a result, we made BS Husky, it is brand name platform from BS Telecom. It is platform for IoT, which means definitely it's a platform for industrial IoT as a subset. And I will try to present evolution of industrial IoT through the one case study, tunnel case study, because it will be what we did really in practice. Industry current state, of course we know that industrial IoT is not the same as consumer IoT, totally different. Sensors already exist. Connectivity only within closed ecosystems, not IP-based, mature market, and existing technology concept suitable is suitable for small-scale system. That's the situation we have it now in each industry. Now I will present you what was the situation with most of tunnels all around the world in Europe. Most of projects for tunnels, I can say it for sure. Situation was situation was I don't know if you see on this picture, but what is the point? Point is that you have a lot of sensors in the tunnel. You have some devices. I will try to be concrete and speak about ventilation system that is very demanding from the perspective of safety. There are some sensors, and you're collecting data from those sensors. In most of projects and most of tunnels, there is one controller, usually it's a PLC. You are connecting data from the sensors, and according to some logic, you will turn on, turn off some jet fan. Let me make it simple. And all the logic was on those points, PLCs or controllers. Okay, it works. Most of tunnels are doing like that, and they are safe. And definitely they are in accordance with standards, all European standards. It works. I will not say what we did right now. I will say it a little bit later. I don't know if... Do you hear me? Okay. First, I will say what are the challenges in industrial IoT. A lot of authors are trying to classify challenges, and they are doing it on different way. Definitely, some challenges are lack of interoperability standards, legacy of existing equipment, no connectivity, embedded sensors, technology maturity, large-scale analytics. What does it mean? There are big data. Data are definitely not structured. Security, big problem. Connectivity, a lot of challenges. But I will not speak about those challenges, what we overcame, what we did not. I will try to say what we are focused on. Our platform definitely can aggregate, or it is aggregating, industrial and manufacturer protocols. It means that, of course, we have now one set of protocols, industrial and non-industrial. But if we want to connect anything, according to any kind of protocol, it is possible. And it is done on the way that it is just one driver. It is plug and play to our platform. And if you put new driver with a new protocol, it will definitely not influence functioning of other functionality of the system. It is very important. So we are definitely not closed in any case. Now we are allowing communication between devices that commonly do not talk. What does it mean? Of course, we do not make connections between devices, but we collect all the data from the devices on one centralized place, and according to some rules, it looks like those devices are talking each to other. We are totally vendor independent. Our platform can work with any vendor. In each industry, we can communicate through any protocol, and that's one of the biggest strength we have. We are focused on defining set of rules based on large-scale data. Because now we have a little bit different situation. We do not have small-scale system. You do not have to take data from few sensors and to control 2, 3, 5 jet fans. Now you have different situation. You have a lot of data, a lot of sensors in one place, and you have to control much bigger systems. Who knows to do it? It's a big challenge. Because even if you are good in your industry, you know how to make program to put it on your controller, on your PLC. When you move logic on centralized place, definitely it is not the same story. Because you know how to behave in case on few sensors, but in case you have a lot of different kind of data and they are unstructured, definitely it is not easy. What we did, as I told you, tunnel works, they're safe. I cannot say it's not the truth. But there are a lot of problems. Problems were because If you want to harmonize traffic on the road, and you have a lot of tunnels, you have a lot of control centers, and you want to put some rule on the bigger section, we are not speaking now about one tunnel. We are speaking about bigger section. We here in Bosnia, we have more than 2,000 rules just for traffic management in tunnels. And if you want to make a rule for a bigger area, in that case, you have to be connected to each device, each controller, each PLC, and to make it works properly. It is a huge problem. It is okay, it will work at the end, but you need a lot of time, and the possibility of mistake is very, very high. What we proposed? We proposed to make Ethernet network inside the tunnel, fully redundant. Usually we have 2 optical rings, so to make it more safe. And we are trying to find devices and sensors that are IP-based, so they can be very easily connected to the network. We have 2 controllers, not thousands controllers, 2 controllers. One in the entrance on the one tube, the other in the exit of the other tube. They are in hot redundancy. All the data are going on 2 places, and all the logic is now in one place. Now you can combine data from ventilation sensors, from meteo stations, from traffic counter, a lot of data, and you should know what to do with those kind of data. Of course, there is a control center on the top, network, and all the data are going to that control center. That was definitely beginning of real IoT, industrial IoT platform. We are collecting all the data on one place, a lot of data, and we have to put new rules how to control tunnel. It is not the same rule as it was before. Okay, how can platform be approached? In any industry, I'm not speaking about our industry that we are focused. We can have a global approach and segmented approach. Of course, we all know that it's not real that someone will say, okay, I will now make smart city. What does it mean? It's quite a lot of investment. It's a lot of infrastructure project, a lot of infrastructure, network, portals, everything. Definitely, and I cannot even speak about services at the end because nobody can imagine how many of them will be there. But okay, we can, if someone wants it, we can fulfill it. We have a platform that is totally unlimited. Usually, it will be done in segmented approach, building piece by piece, integrating solution, and data sharing. What can our platform? Horizontal and vertical extensibility and scalability, and it is distributed architecture. What does it mean? In the sense of IoT. And it is very important. And any platform that should be IoT platform, definitely, I don't know any other way it could work. What does it mean? That we are trying to make a network of control centers. And okay, all these control centers, they have their data, and they should be connected in somehow. Okay, you can do it on the old-fashioned way. You can connect each control center, each to other. There is some protocol. You will exchange some data. You will transfer data from one to another. Then you will do something. Okay, that's one option. It will work. What does it mean, distributed architecture? It means that we are making one hierarchically higher control center. That control center see all the other control center, and you can make rules. You will connect all the centers through this one. It is very easy, and now if you want to put rule for all those control centers, you will make it on a higher level and you will just put it in the system. Everything will be done by itself. It's definitely something that will make life easy for all of us. We are trying to implement these things, and that is definitely more safe. And safety is very, very important, especially if we speak about tunnels or some other very, very important things. We support a limited number of sensors. Of course, hardware is a limitation factor, but you can scale it. And process definitely a large amount of data. What is conclusion? BS Husky is an IoT platform collecting unlimited amount of data. We can connect unlimited number of locations, making one system. That's very important. Everyone can connect a lot of locations and integrate them. This is different. This is one system. Of course, we can integrate. If all locations are not made with our system, we can integrate with anything. We are totally vendor independent. We can provide unlimited number of services, exposing data to external services in any way. We have definitely extendable logic, and trying to put some logic in production is definitely easier. We have those distributed architecture. I said what is the importance of that. Data analytics and presentation of data in any form and any device. It does not mean, of course, if you want some mobile application that you will have to make, of course, every IoT or programming company can make application if they have good programmers. This is something different. We have specialized clients. It looks the same. You just click what you want to have a mobile application and put and make your mobile application. This is a platform applicable to all industries, but we do not work in all industries. Why? Because we do not have a knowledge. I will again point that is the biggest problem. We can control nuclear power plant or something, but we do not do it because we do not know. That's the point. We are specialized in traffic management, water supply industry till now, and logical implementation were smart cities. I will let you.
First of all, let me greet you. Good morning and hello in my name and in the name of BS Telecom, and welcome to IoT Summit 2017. In the next part of the presentation, we will be going through how we see our platform in smart city environments. We will first see what are smart cities. We can say that smart cities represent a combination of smart combination, or I could better say smart union of urban infrastructure, technology in order to provide a society a better quality of life. Smart cities evolved as a reaction of global urbanization. Smart cities are trying to solve the global problems of urban infrastructure problems. Data that was in closed systems now becomes available to public smart community. That data now can be used to make smart city services. So we can say that smart cities are based all around smart city services that should be provided to smart community to help them ease their lives. BS Husky is exactly the platform that makes smart services happen in smart security environments. Let's see how. On the next slide, we will show BS Husky architecture. Main goal in smart city environments, as we said earlier, is to collect all data from all sensors. That data should be processed, analyzed, aggregated, and presented to end users or external applications. In our case, we tried to make smart city services. How do we do that? BS Husky architecture has a key component. That's a communication component that allows us connectivity to all the sensor. We are a vendor independent. That means that you can connect any sensor, no matter which vendor sensor. You can connect it to our architecture. Data gathered from those sensors is now being analyzed, processed, and a set of rules can be applied on that data. Raw data or processed data then can be given out of the system through APIs to external applications or external users. These four components, communication, processing, presentation, and APIs, represent the main key components in BS Husky platform. Now, when we look at this picture as a whole, you see that what I've shown you here really represents an IoT platform. That's why we can say that this really is an IoT platform, and we focus on those four key components in our architecture. Let's see how we can apply that platform in smart cities. BS Husky platform, as we earlier stated, is a platform where you can connect anything, apply a set of rules, manage that data, and export that data to external applications. But BS Husky is more than that. BS Husky, with our knowledge and our solution, provides inbuilt set of features that you can build on smart services. So let's see. BS Husky platform has already some features that we can use to provide smart city services, like smart traffic management, traffic information system, lighting system, ventilation system, incident detection systems. BS Husky platform features already communicate with sensors and acquire data from all sensors, like traffic jam, vehicle count, speed, illumination, video detection, fire alarms, ventilation systems, and so on. So we see our platform as a key component to make smart services like smart traffic management, smart public protocol, smart parking, smart lighting happen in smart city environments. Okay, now that we know what the platform can do, we want to share you insights in what we think is the key goal in making the smart city services usable in smart city environments. It's the data utilization. You can try to connect one service, make it as a standalone smart city service, but you work with a set of data that is limited. End goal is to connect all smart city services to one platform and share that data because interconnecting sensors provides more reliable information. Combining data may make more precise analysis and predictions, expose data from one service to another smart city service, and provide real-time and accurate information to end users. Let's see some appliances from those BS Husky features that I spoke on earlier. Let's start small. One of the easiest smart city services that the BS Husky can provide is smart traffic management, because we have the feature TMS, traffic management system, that already knows what communications what sensor you should use to provide this service, what is the difference between sensors, and what will you gain when you use different types of sensors in this smart traffic management. Also, our solution already has defined a set of rules that you can use in smart city environments to provide smart traffic management. This is an example of a dashboard we can present to end users, combining all data from all sensors. It shows the key parts of the Sarajevo that are currently have sub-problem detected. Details you can see on other sides. There are, you can integrate data from weather station. You can combine data from vehicle counters, inductive loops, radar, semaphore. You can get the latest detected vehicle and aggregate its data to one easy understandable picture, and you can make data analytics and statistics based on that data. Let's see what you get when you combine all sensors in the traffic management field. For example, if you want to have data from speed, vehicle length, you could use radars or inductive loops. If you want to have automatic number plate recognition, you could use automatic number plate recognition cameras, or you could use radars. Vehicle categorizator, video detection cameras to track the incident detection violations. If you don't have these sensors, you won't have this data. So you don't have the full picture of the traffic management system. Let's try now to build upon this service. The goal is to interconnect smart city services so they can share data. Data is, let's try to build upon this early service. Let's look at this smart ambulance service. Smart ambulance service, it can be easy service to implement. You receive a call 911, accident happened, the ambulance sends vehicles to the site, and that's the basic version of a smart ambulance service. But if we combined data from smart traffic management, the service I spoke earlier, with smart ambulance, you get the bigger picture. You get more eyes, so to say, on each side of the city, smart city. So if accident 1 and accident 2 appear in certain locations, smart ambulance uses the data from a smart traffic management system, calculates the fastest route, avoiding traffic jams, and bringing the vehicle to the accident place. That's one example of interconnecting two smart city services. We can go even further. Why do I have to wait for 911 to ring, wait someone to call and tell me that there was an accident? You can track accidents with incident detection systems that is implemented as a feature in BS Husky platform. So let's keep this down a little bit basic. Let's see, what does incident detection really mean? Incident detection as a sensor uses the camera. Camera is one of the sensors that is the most applicable and most common in smart cities areas, but it is least used. Our solution, incident detection system, uses the camera as a tool to provide knowledge, insight in traffic safety and traffic incident detections. As you saw earlier, you can track vehicles. You can track vehicles just by looking at the stream. This is the view that video detection camera sees. As you saw, vehicle when enters the site of the camera is starting to getting tracked. It's real-time tracking. As you see, the small boxes are generated in real time, so you get the route that the vehicle is taking on the road. So this is the basic version of it. Let's work with this basic version of incident detection. You can build a smart city service on it. What smart city service? You can, for example, build a vehicle tracking service in smart cities. If your smart city is covered enough with cameras and incident detection places, you can get the route the vehicle was taking when going from point A to point B. Now, this opens more possibilities and more other challenges, but this is the basic approach. You track everything on the roads, you combine that data with other sensors that we spoke earlier on, and you get identification of the vehicle, and you can see its movement through smart cities. But incident detection is not only tracking vehicles for the purpose of GPS tracking. It can do much more. Now we will show a few illustrations of how you can utilize incident detection to its fullest. In this illustration, you will see scenarios of forbidden turn and automatic number plate recognition sensors. Let's have a look. The vehicle should only be allowed to go straight forward because he should not be able to, is not allowed to go in one-way street. This is a viewpoint of the camera. Camera detects this violation, and the ANPR camera detects the nameplates of the vehicle that has made the violation. Let's look another simple illustration. Incident detection scenarios, stop sign violation. If you see a stop sign, you have to have to stop on the stop sign, look left and right, then include your vehicle in the right lane. Green vehicle does it right, stops at the stop, but the red vehicle violates. The camera detects that this car did not stop for at least X seconds on that position. The ANPR camera detects the vehicle number plates. Okay, these were two easy illustrations where you have one detection, one camera, but one camera can be used to detect multiple violations. For example, in this illustration, we will see red light violation, solid line crossing, U-turn, and identification of the vehicle. Let's have a look. The red vehicle crosses the solid line, does the U-turn. This camera doesn't see the red light violation. Other camera can be used to detect red light violation. There. So the software now does the combining of data. This camera gives us the solid line crossing and the U-turn. The nameplates cameras give us the nameplates there, and we have the data from other camera that detects that the vehicle has driven through red light. So you get what I want to say. The possibilities are endless. You can map all the traffic signs on each crossroads in this platform. Let's have another look. Another look illustration represent current speed detections, combining data from radars that can detect the speed, average speed calculation provided by incident detection system, and unique identification of a vehicle. So the red vehicle drives through two crossroads. On first crossroad, we detect its current speed and the time that vehicle was on that position. And then we take the data from other crossroads and calculate the average speed that took between these two crossroads. In this example, we want to show that you don't combine only data from one crossroads. You can scale that up to whole smart city environments. Okay. We identified, as I said, a video camera as a very good sensor, but least used, but mostly spread across smart city environments. It's easy to install, easy to use, easy to integrate on our platform. Installation on existing infrastructure is easy, and it has a multifunctional application. As we saw, the incident detection scenarios that can be detected are red light violation, wrong direction, wrong turn, U-turn, solid line crossing, stop vehicle, unique vehicle identification, pedestrian on road, object on road. So you basically see that there are no limitations. It's up to you what you want to track on each crossroads in smart cities. Okay, now let's go to summary. As the end result, we can say that the BS Husky platform is a platform for IoT. BS Husky platform has the inbuilt set of rules and features that can help create smart cities, which are subset of IoTs. Our goal is to use existing infrastructure and existing sensors with their full potential in order to provide smart city solutions with minimal investments. Our vision is to expand BS Husky to be equally efficient in other industries, like water supplies industries, to be more smart, to be more safe. Thank you. Imamo vremena za pitanje. Q&A.
Back to tunnels. You referred to safety. Let's imagine there's no electricity, nothing's functioning, and people are continue to drive through the tunnel. What becomes unsafe? What is the safety issue for a driver? How are your systems actually keeping it?
It should not be possible that there is no electricity in the tunnel.
No, but everything just falls.
Everything, but
Your whole system just stops functioning.
I think no, it is not possible. Why I'm telling this? Because you usually have double power from both sides. You have some generator. There are a lot of things. You will know when anything happens. You will know first. So you will not allow people to drive through.
What is the safety issue? What is it that's unsafe? What is it you're maintaining to keep it safe for the driver? If the whole system fails, there's still a hole, there's still asphalt, and I can drive through the tunnel.
Okay.
So what is it that becomes dangerous if the system stops functioning?
There are different things. It depends on the length of the tunnel because of gases. If there is some incident, smoke can be detected much before with camera than with any other system. In Austria, there were some tests. It is 20 times it will be detected with camera than with any other system. But if nothing works, nothing will happen. People will drive through. If there is a big tunnel, and especially dangerous tunnels are with both directions, then there is a big problem. It is a big problem because smoke can kill all the people in tunnel in 3 minutes. It's very, very big problem. So there is no much time for the reaction. That's why usually we are trying to make speed of air in the tunnel to be constant, to be around 2 meters per second. So if something happens, that it will be definitely better position, starting position. So because if there is no flow, there is no air, fire will not go all around. But if safety system, but it is not, it is, I don't know, I cannot imagine because, okay, we are not doing those high voltage electricity and we are doing low voltage. But I know that there are a lot of different, especially with power. I don't know how is it possible.
So the bottom line, really practical issue here is oxygen, so people can breathe.
Yeah.
Meaning if
No, they cannot breathe if there is.
If the fans stop functioning, but there's no accident, is there still a risk that there's just not enough oxygen? Or do you?
It depends. It depends. If it is a big tunnel, it depends on the airflow outside of the tunnel. But if maybe natural flow of air around the tunnel and inside the tunnel, usually there is some natural ventilation. Usually, and there will be enough air in the.
So the danger is if there's an accident or if something goes wrong, you need your systems in place so there's a quick response.
Quick response. That's the. But for example, what is new with what we brought with this platform? One example, you have visibility sensor in the tunnel. Okay, if there is something, some fog or something, or some smoke, it will react, and you will start to turn on jet fans, and you will clean it. But sometimes, because of natural ventilation, some fog will go into the tunnel, and you are not able to decide, is it fog or it is smoke? You do not know, because, okay, and on the camera, you see something is going on, but you are not sure where it comes. So we started to combine sensor in front of tunnel from meteo stations, fog sensor. And before, it was not connected. Those data were separate data. Now we are combining. If we see that there is a fog in front of tunnel, and we have some alarm on visibility sensor in the tunnel, probably it is not smoke. It is fog. We are trying to combine, and those rules, we are improving those rules. And ventilation, before you had PLCs, and you could turn on, turn off only few sensors, few jet fans in the field. And you have a lot of PLCs. They were not talking each to other, and it was like that. Now we collect all the data in one place, and we are trying, now we have full picture of tunnel. And definitely reaction is faster and reaction is better.
What is a PLC?
Programmable logic control. It's like some module. You are connecting sensors and you make some logic. How will it be? It's IoT in a small. Definitely. You are connecting and you can expose data from PLC somewhere. But it is for small scale system. That's the difference. And so you cannot put, they are big PLCs, they are huge, very good machines that they can process a lot of data. But it is not unlimited. You're limited. All the time you're limited. And connection between them, even they are produced from any manufacturer, it is not easy. So our strategy, network is something that is reality. Everything, network is like cloud. That's it. And in tunnels, when we started to say, no, it is not a cloud. Because they were doing safety systems, they are quite conservative. But that's reality. That's reality. And you have one PLC, okay, it's reliable. But definitely, if we have two controllers, they are industrial controllers, hot redundancy, all the data are going to both sides. It is more reliable than one PLC, because if it is down, that part of the equipment is down.
I have one question regarding the smart management system. As a lot of cameras have already been deployed to different cities around the world, I am wondering how much of these cameras you can reuse actually, because some of them are analog cameras, some are digital, different shapes, different resolutions. What are like the minimum what's the minimum level of the cameras you can reuse in order not to deploy new ones?
Okay, I will just say one thing. When we started this traffic management, especially for tunnels, we were in Slovenia. They have quite impressive, quite nice control center. And we told them that we would like to make incident detection on IP cameras. They told us, no, it is not possible. It is not possible. You cannot do it. If you do it, please call us to see. But we could not even imagine to put analog cameras to make incident detection. You will not be able to buy. Now, we have some projects somewhere, I will not say where they're old projects and they do not want us to change anything, and they are analog cameras, and it is really not possible to buy analog camera. But we can use, maybe Nadim can explain what are the minimum of data.
It's reusable, definitely. You need to have a stream with, you need to have a reliable stream data, continuous stream data, and I would say the main things that makes incident detection is the position of camera. So you need to have the right angle to detect the right scenario you want to pick up from the crossroads. I wouldn't say the camera is the problem. I would say just the positioning, the tweaking, the position of the camera.
Where is the analytics done?
What?
If it's not
In the center. In the center. It is not on the camera. It is not on the camera. We were also thinking about those kind of things. There are top 3 producers of those kind of softwares. A lot of them can say that we have it in camera, inbuilt. I can assure you that it is not the true. I will not say names. We bought source codes from one of them. Source code. That's why we have such a good position and the starting point. We did not develop it from the beginning in BS Telecom. It was one of top 3 softwares, definitely in Europe. I can see.
Yeah, my question was also referring to, you mentioned license plate recognition, and there are like huge problems with that because it's not just a clear, you can't rely that each car has a clear, very visible.
It is not 100%.
How many percent, you have a clue, how many percent of these, like analog cameras or their images can be reused to detect how many of, let's say, license plates? 90%, 95, 50?
We do not use same camera for license plate recognition and for incident detection. They are completely different because license plate recognition is definitely more focused. This one is very wide. And we do not like some good cameras with the high resolutions because we do not need it, because changes will be seen. And problem is that you need a lot of processor power if you have a very, very high resolutions. Definitely in the future it will be better to do incident detection with higher resolutions. But we do not like those, I will say, cameras with a high resolutions.
So very impressive, very scary, this detection stuff. So if it's already implemented, I need to know that.
Okay.
Second thing is, are you already working on initiatives in automotive as well to, let's say, self-driving car initiatives are going on to combine your results together with your initiatives?
We are not.
That's the next step.
We are not, definitely that's the next step. But we are not involved. Actually, we have implementation in tunnels. Problem is lightning and that percentage of reliability. Because it is probably 97%. If you have a good light. If you do not have a good lighting system, it will not work because you will also not see it. So camera cannot do it. So that's a little bit a problem, but it is a future. It is a future, it will come.
My question is, sorry.
How do we, sorry, deal?
How do you cope with fire, in case of fire in the tunnel? Because a few years ago, there was a tragedy in the Alps.
Yeah. Usually, what we are doing, we are demanding from the projecting house to put a request that airflow in the tunnel is on one reasonable level. What does it mean? It's usually around, as I told, 2 meters per second. It means that there is no big speed of air in the tunnel, because if speed of airflow in the tunnel is high, then, and if you have a fire, it will be all around in 1 minute. So that's definitely first thing we are trying to do. Then we are trying to detect it, because you will not have first fire, you will first have smoke. And our incident detection works on the way that when it loses visibility, we detect it. And definitely on the smoke, you will lose visibility. And we are trying to detect it. In tunnels, problems are not fire, problem is smoke. And we are trying to detect it, and everything can be automated. But we are trying not to automate these things. And it is not allowed, because police and fire brigade will come, and they will decide what will happen. But at the end, someone has to decide who will die. Because he see everything, he see people on one side, on the other side, and and if he start to extract smoke on one side, everybody will die on that. And someone has to say, okay, it is my decision, and go with the extraction on that side. And that's the way. We can do it automatically, but usually we do not like to do things automatically in this very, very critical thing. And it is not allowed. Fire brigade has to say who, because, and firemen can die also. It's a definitely very complex topic. Smoke in the tunnels, extraction, it is special, like, we need special knowledge for that.
How many big and powerful computers you need to process all those information from camera that you can easily take from simple sensors that doesn't take much power or processor power?
Which do you
I don't
know?
get that part.
It depends how many streams you are connecting on the.
Stream by itself, it's already.
Yes, the stream, you have the bandwidth to get that stream, but processing is done frame by frame. So you have to have big processing power to analyze all frames in the video. If you connect more streams to the server, you will need even more processing power, but that is the key part of the incident detection system, how to keep it low so you can get more out of it. So you minimize the quality, as Nerma said. You don't need extra big quality for this. You need the right amount of quality to enable your software to work and to process that data. So I would say you don't need something big to work, but if you attach more streams to it, you will definitely need more processing power. Depends what you want to do.
Well, I'm okay with some combination, but I didn't get the part. Why would you replace cheap and nice IoT device with doing all that with cameras? Because if you're doing all that processes and calculations, you need a lot of power, and so you eventually invest a lot in the processing computer that is replacing cheap and good working device.
Sorry, but what is a sensor where you can use?
I'm okay with combination you mentioned. Okay, camera is just visual, and you combine with the sensors, you detect smokes, but doing the calculation of speed and rest, I don't understand, because it takes a lot of resources right now. That technology.
Usually, we will not replace radars yet, but it is the future. Camera will replace radar, believe me, because it is multiple sensor. Our percentage, we are measuring speed, but we have mistake maybe 5 or 6%, and it's not allowed for the police. But camera, believe me, there are, and it's you cannot do it. You cannot measure speed with one camera. You need at least 2, and it is completely different logic, different mathematics. It goes through angles. There are companies, I know, 2 of them. They are doing it with camera, but it is the future because you will not use that camera just for that. You will use it for a lot of other things. That's why it's the future. And for these things, there is no sensor you can detect. Okay, you can do everything with inductive loops, but definitely. Actually, in traffic management on the highways, they have their own, it's closed ecosystem. They have their own network, so it's not a problem. We, as a company, usually, we are trying not to take care about connectivity. We are giving it to someone else to provide it for us. As we said in the beginning, we are not trying to divert. We know a lot about connectivity, but we cannot do everything. We are focused on those things where we are best. Yeah. Thank you.
Okay, thank you.
It was a 1 minute. Thank you. Thank you very much.